So I'm thinking about how to implement lambdas. To start us off, we're going to need to parse them. So we already parsed the syntax for a lambda because scheme is really simple. But we do need to recognize them when we bind. So what we need to do is, in the binder, check and make sure that the body of whatever we've been given looks like it's a lambda. So a lambda, just going to get the special form definition. Oh, make it really small. So our lambda special form starts with the word lambda. So we need an ident node. And then has formal arguments and body. So formals is just a single element, and then we'll pass it later to decide whether or not it's a list. So a lambda is actually a definition. But it isn't, no, it's not a definition. It's the value there. We don't have a value yet. I think we need a bound expression type for a lambda. Which is going to take a list of bound formals and body. So you can find bound form. Bound formal is going to have just an ID, I guess. That's the question. So, body of a lambda shouldn't be, here we're binding it in the context of the parent scope. So I think what we need to do is create a child scope. So bind context has just a new scope. So I think a binder context needs to have a scope and also a parent. Good. So when we create the body down here, create with parent. Let's define a create with parent. So with that defined, we should just be able to call lambda context equals binder context create with parent the current context, and then instead of binding I was expected to have option because we want this to be some parent. Then we can pass the lambda context in. So the thing we still need to do is bind the formals. And I need to learn how to list. Yes, I do. This isn't C#. It's been a long time since I've written any F#. So yes, our body is a lambda with formals in the body. First thing we should do is try and bind the formals. What do we really need to do to bind the formals? Well, I haven't really said what the formals is yet. It's just an AST node. So because if we look at the definition, a lambda could be just a single identifier to bind all of the arguments to. It could be a list that defines what parameters you get, or it could be a list with a dot. We also need to fail the parts. This is not formed lambda. Someone else's problem to deal with the bound formals and pass those in. I also think that once we've got the lambda context, we would want to go through each formal and add it to binding. So I'm about to do that. and implement button format. So, you know, the formals is an ST node, so we're going to match it. It could be a ST node .id. Okay. In which case we want to return a list containing just the ID. That's to be that's just a type errors, isn't it? So bound formal is a string list. ST node, it could be a sequence. If it was, you would have to loop through and turn them all into so we would have to do this. No. So the thing here is that if it's a sequence, just we'll just fail because of time. Why is this not find format is not suppose I can't type. Well, that appears to at least compile, unless it does in this file. Ah, yes. So now we actually need to lower this. So in the interpreter, we will just say we don't support lambdas because the texture needs to be deleted. We have better ways of doing that now. I might as well tell people what it is that's not supported. Just A. Okay. Then for the compiler, I'm tempted to just shell out some of the method here. So, because the lambda is going to have to be lowered as a separate method, and the way we do that at the moment is we define our script body, we create create a context for that method body, and then we call emit expression. So we're going to want to call emit expression on the lambdas body at some point. But I don't know whether or not we're going to want to do that from within this emit expression, or whether or not we want to have another emit, like we've got emit sequence and emit application. Well, emit application doesn't do anything at the moment. I think that's what we're going to do. I think we are going to just call emit lambda. Just for that. It should be good enough that we can at least just run it. Might even work. So hopefully we should be able, we've got our prompt here, we should just be able to do lambda x and then somebody, which is enough for the time being. And that should get turned into value, but should, oh no, it's an ill-formed lambda special form. Wow. Well, the body is length 2 for a start. Because, yeah, of course it is. Yep. Let's do that again. This is taking so long. I have a feeling it's because it's not working. So, typical. Yeah, can't lower lambdas. But we can at least check that we have the right set of formulas, which is x and the right body. So, lambda, if we're going to omit it, lambda is basically a function, and it'll have a body and the arguments. So we'll need to build up a method declaration in emit lambda. Let's write these out as to do comments. So we'll emit a method declaration, and then we will emit the body method, emit expression. And to do that, we'll need to create a new context based on the current one, but with the new method. And then the last thing we're going to do, which is if you write the scheme for, well, in our scheme at least, every expression has to have a value. So in the end of the day, this will actually turn into a reference to the lambda. So the first thing we'd want to do is well, for the time being, we could emit null, but we would want to return a reference to the method. And it may well be that if the parent scope is just defining a bunch of different functions or something, they all get discarded straight away. But what you do want is the ability to write some scheme that would look a bit like and then be able to call that with x and have it return the search. Have that return. So to be able to do that, when you define this lambda here, we also need to return a reference to that method. So then you can store that in this x, which is going to be the local variable of the outer scope. So we already emit a method declaration for our main method, so hopefully we should be able to deal with this quite easily. So we've got our script body. So I think what we're going to want to do is do context.programtypes.add a new method declaration. And we want it to be static. So I'm just going to copy this. And I'm going to copy this. Well, which parts of this do we want to keep? Which parts are actually parameters? Well, script body is the parameter, isn't it? Really. So we can just take this. We can change this. To be turning a. So down here, the main method wants to call the body method. So we need to have a reference to that. So I think what we want is something that looks a little bit like let call this lambda. Well, actually, the idea of a named lambda is slightly interesting, but this is not Emacs. We'll give it no formal arguments because it's the script body, but we will give it the bound expression as its body. And then we can take this, change this to be emit named lambda. Just takes a name and a formals and a body. What are we missing? We are missing the context, which I think we're going to have to give it a hint. Is an emit context. And then we can do context.logtype. If I call it program type. And emit expression, we can't call emit expression because we're above it. These two are going to be mutually recursive, which is a pain. Nice. If the way for those not to be mutually recursive. That's going to be context, current contexts, assembler, types. Can I just take all the rest of it from contexts? Is that too JavaScripty? It's too JavaScripty. Use the assembly and program type from the context. Create a new context. Body method is going to just be method declaration. For a new method declaration, use name as the name. I'm going to ignore the formals for the time being because we're not doing arguments yet. Body is what we're going to emit, and then we'll optimize it and turn the method declaration. So when we emit a named lambda, we're going to emit the lambda and then return a method. have to emit the implementation for the lambda. So it's going to be emit named lambda. I'm just going to call it lambda for the time being. I have to work out a way of making new names for these. Formals and the body. And then we need to pass in the emit context. And then we can do just going to be load into load static, I think. We'll use it load null for the time being. So this should at least return null when you write a lambda. This is because express doesn't match. It emits using its parameters wrong. Yes, found because emit lambda needs to use context here. So we need to the other option instead of passing the emit context into emit name lambda is to pass the individual parts in. Or we can fabricate an emit context with no method. IL processor. I could just try giving it null. See what it implies. I think this would be prog type. And Assem is current assembly. And then we should be able to use context here. And when it creates the derived init context for the actual script body. It's just going to overwrite the null IO processor. Right, that should work. What is this? I'm seeing a red somewhere there. Somewhere to the right of here. Yes. Method needs to be context.asm. So we're not using the formals yet, but that's because we are being lazy. So the idea here is going to be that eventually we'll loop through the formals and transform them into the parameters for the method declaration. So I guess the first thing to check here is that we haven't broken anything, so literals and things should still work. So I'm just going to try the good old hello world with an exclamation mark. Yes, that still works. And numeric literals. Yeah. And then if we do a lambda, we end up with a null, which in schema is the empty list. But if we go and find our lambdas file and just change this, let's see what that compiles to actually. So if we run our compiler, I can't remember if it actually takes proper command line arguments and things like that. So I'm going to have a look at the tests and see how it calls the compiler. It's been a while since I've looked at this. Spec tests call the compiler by calling .NET. That's after it's compiled it and calls compile file interactively. What does our program actually do? You can do any number of things and it compiles those files. So if we do spec lambdas, it should, oh dear, what a shame. Application is not implemented. This is because we're trying to actually use the lambda value. I'm just going to contact that line for the time being. And now if we do I'll do dumpil on spec lambdas. Let's see, you should be able to you know the dumpil. Yeah. another diff. So if we do my diff spec lambdas.exe, yes, this is what we want. So we can see the IL. You see our main method, which has always been there. We've got the script body, which calls load null, which is where it's loading our reference to a lambda where we've not implemented that. Stores it into local variable x, and then returns the copy that it just duplicated, and the lambda itself, which just does load constants 100, and then boxes it up and returns it. So that's working quite nicely. So there's a few different places that we need to look into fixing here. We need to make it so that this lambda is not called lambda, because if I do this, if I define something else, I mean, I could define that as y. I mean, this y here and this y, if I was to put y here, would not be related. But if I do this and then compile it again, see that if I ended up with two different methods, both called lambda, which is a bit of a shame. And I imagine if you were to try and run that, well, no, it's happy. Probably because we never actually try and use anything there. That's interesting. I didn't know that you could do that with IL. So yeah, the first thing is go and make it so that when we compile, so yeah, in the IL we've got more than one lambda, or they're all called lambda, and it's because of this. So I think what we need to do is somehow or other keep track of a name. Now, as we go down the tree, what we could do is have, in our emit context, we could have like next lambda, And then as we walk down the tree, we'd increment next lambda. The problem there is that if you go, because we're storing all of these as static methods on one class, you would end up with something called like lambda 1, and then you'd go down and you'd call it lambda 2, but then if you had two lambdas at the same scope level, you could end up calling them the same thing. So I think what we need to do here is keep track of some kind of lambda nesting as well. But we can't just keep track of how deeply nested this lambda is. So I think we need some kind of scope prefix, which is a string. And so when we create the initial context, we've got to new those up. So we can set next lambda to whatever we want here, because we're not going to use it. And then we can set scope prefix to $root or something like that. And then when we recurse and go down, what we would do is we would say, first thing we would do is get the current lambda, which would be context dot next lambda. And then I think I want to do tx dot next lambda. Is the next one. That is not suitable. Mutable. How about that? How do I do a mutable field? That's been a while since I've been really extra. I don't seem to have done. So I just started with mutable. Okay, so I was right the first time. Yes, okay. Mutable next lambda. And through here. So I can do that now. No. So we update our next lambda for the current context, and then we create a child context we'll start next lambda back down at 0, but the scope prefix is going to be the current scope prefix with and then so it's going to be context dot land scope prefix and then lambda ID of the current lambda. So as we go further down, we'll end up with unique names. So if I go there, run it again, and then look at the disassembly. That has still been called lambdas because we didn't use scope prefix or anything. That was a bit silly. I think we've done that wrong. So in emit lambda, we that's my work. So when we actually choose the name for the method up here, we want to use it's just context.scope prefix plus the name, which is lambda. Try building it again. Disassembly. We have ended up with two lambdas called the same thing again, just with more stuff pasted on the front. So I think what I was thinking initially, slightly wrong. So I think it's because both these lambdas are in the same context, so we're creating new scope prefixes each time we come down, but we're not actually using the next lambda in the name. So I think what happens here is we probably want to do this. What do we call emit named lambda? We probably want to take this bit and move that up here. So you get a new lambda ID, and then we use the scope prefix and the name of the current lambda is the two parts of our next scope down, and then up here we use the scope prefix and the lambda ID. Okay, and let's just do it on a run without no build. That should be a little bit simpler. I only did that the first time because I'd only just built it. And resting. So yeah, so we got root, this program root script body lambda 0. I would expect that to be dollar script body dollar lambda 0. I mean, it'd be nicer if that was colon dot script body colon dollar lambda 0 or something. Just because sprinkling dollars on things seems like a nice way of doing it. Although a colon and a dollar is a delimiter does seem a bit over the top. So yeah, we could just paste those two together. So the new scope prefixes, or the new scope prefix, the previous scope prefix colon the current lambda name. So when we say, is this going to exponentially explode? Because we're putting the scope prefix on here, and we're putting the scope prefix on up here. I think that. Yeah, and that's going to explode. What I kind of want is that to just be there. We already have the scope prefix, and then we take the name in here, and when we define the name, we would do well, actually, it's just this, isn't it? Again, We can use that for the method declaration. And just to prove that that is going to work, go into the lambdas and define a second lambda inside the first lambda. And define so then this one can just be the 1, 2, 3 or whatever. Okay, so hopefully we should end up with 1, 2, 3, 4, 5 different lambdas when we compile this. And I'll do it with my technique. Patient here. Why's the build taking so long? Because I'm running it from all over the place. So we've got root script body lambda 2, root script body lambda 1, lambda 1, lambda 0, root script body lambda 0, lambda 0, lambda 0. Right, so that means that everyone's got their own unique name for the lambdas now. I wonder what the script body ends up getting called now. Is that going to end up being called $root $script body? It is. This probably means we've broken. Yes, that means we're going to have broken the interpreter because it won't be able to compile the evaluator because it's trying to create a main function that calls into $script body. Or is it? It's not doing it by name though, so let's see. We run it and we type something in. Something that will actually work. Yeah. What has gone wrong there? So main calls body method. No reference. I'm not quite sure why that fails actually. Let's find out by debugging it. Because as far as I'm aware, this body method should be what's emitted by the name lambda. Should just be a call to the method decal. wonder if it's because we faked that IL processor to be null. Method.invoke. Ah. No, it is this here in the evaluator. So we could probably get the evaluator to still emit $script body. So emit name lambda is just, what's it doing here? It's using the whole lambda name as the scope prefix. It's not actually using name for anything other than that. So we could just move this back up here to be context.scope prefix, and then we do same. So we have the scope and then the lambda and then lambda ID. So we always emit the full name, and then in here we just use the name that we were given, and then when the root method calls emit name lambda with $script body, it should still emit it as $script body, which means that the eval method is capable of looking that up again. I think if this builds, I think we're done for today. Well, if it builds and works. And I didn't need to switch it. So, yeah, it's still working. We can even do and that's still null because we're not actually properly emitting the method reference yet. But if it was, then you would end up with whatever we choose to decide is the external representation for a lambda method. Well, some success. I hope this has actually been slightly interesting. And let's get some time to work on this compiler. I'll try and live stream it again. Does anyone have any questions before we go? Doesn't look like it. Well, thanks for watching then, and see you next time.